Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to continue our discussion on descriptive statistics by talking about measures of dispersion. So in the previous video, we talked about the central tendencies with mean, median, and mode. And in this video, we're going to talk about the measures of dispersion, talking about deviation from the mean, variance, interquartile range, and standard deviation. And so what I want to do in this video is actually go through these. We'll probably go through two of them in this video and then two in the next, talking about these four measures of dispersion. But I want to make sure that we have an understanding of mean and median as they're going to come into play for the measures of dispersion. So just to recap, median was you ordered the data set and then you found the middle observation, and then that value was the median of the data set. And that meant that 50% of the values were above it and 50% of the observations were below it. Mean was the average, and so we added up all of the observation values and then we divided it by the number of observations. So let's go ahead and talk about deviation from the mean. So if we scroll down here to deviation from the mean, deviation from the mean. Right, and so we already know the mean is x bar, right? We've covered this in a previous video. Deviation is just a fancy word for subtraction or difference, right? So this could be interpreted as difference from the mean. So what we're going to do is for each observation in our data set, right, we're going to take and we're going to subtract the mean from that data set. So we're going to minus x, and then I always put a little I here just to indicate that we're doing it for every observation. Okay. This is deviation from the mean for one observation. So if we scroll back up a little bit here and we grab our mean, which was 5.54, I'm going to write that number over here. Write our x bar from the previous video we said was 5.54, right? And so for this first observation here, the 6.4, right, the deviation from the mean would be 5.54 minus 6.4. And if we do the math on that, we get negative 0.86. Right, so that means that our value here was 0.86 higher than the mean, because this negative, right, when you subtract a large number from a smaller number, you get a negative number. So this means that our value is 0.86 higher than the mean. Okay? And so what we could do is we could do this for all of the observations, and we could take the average. Right, so if we sum these up, so then this is for, let me make a note here. This is for one observation. Right, that's for one observation. If we wanted to do it for all of the observations to get the average deviation from the mean, right, it would be x minus xi. Right, we would sum those up. There's that sigma, or that e again, saying that we're going to do x minus xi, sum it up, and divide it by the number of observations. So this here is going to be the average for all observations. Okay? So let's go ahead, and what I'm going to do is I'm going to show you how to do this in Excel just to save us a little bit of time here. So if we open up Excel, this is the exact same data set that we just had. I'm going to copy this set so that we're just dealing with height. Okay, so we have height. I'm going to calculate the average. So to do that, equals AV, and you'll see it says average. If we double click that, I'm going to highlight those and close the brackets. So we see this is the average that we would have calculated before. So to calculate the deviation, we do equals x bar minus that. So this is the same value that we got before. Again, we're going to click and we're going to drag. So we can see here that most of our observations are actually above the mean. Oops. We actually need to change that equation slightly because we need to do dollar signs there to make sure that we're using the same value each time. So now if we do that, there we go. Okay. So this is the deviation for each observation, and then we're going to sum that up, and we're going to take the average. Right, so if we take the average of these values, this value is basically 0. That value is approximately 0, right? E to the negative 16 means that that's very close to 0. So what does this mean? This means that the average value is fairly close to the mean, but there's a problem here. And that problem has to do with these signs, right? Because negative 1.26 is going to basically cancel out 1.3, right? And 4.43 is basically going to cancel out negative 4.6. So what we're really seeing is that we have values that are high and values that are low, which means that we're basically canceling them out. So what we can do to fix that is absolute value. So if we take the absolute value of our deviations, which basically gets rid of the negative sign, right? By doing that, now you can see we have the same values but not negative, and if we take the average of those, you'll see how the value drastically changed. And so this is saying that we don't know which direction it is, but on average our values are 0.68, in this case feet, 0.68 feet from the mean on average. That's what this value means. But we don't know the sign, whereas this is saying that it's basically no deviation from the mean, but that's because we kept the sign. So hopefully that made sense. This video took a little longer, so we're actually going to stop here, and we're going to pick up with standard deviation and variance in the next video. So hopefully this made sense, and if you have any questions, as always, please reach out. Thank you.